there is to see. So it's a pretty exciting experience.
But before we get the chance to appreciate these mesmerizing images, they need to be tweaked.
The human eyes can only see a very narrow part of the spectrum, your blue to red, but there's light on either of the other sides of that spectrum. And of course, JWST is infrared, so it's on the red side of light.
Right, so Webb is an infrared telescope, so it's sensitive to light that is beyond what our eyes can see. So that's 2 layers of adjustments.
It's the job of the data image developer, part science geek, part artist, to take this invisible infrared light and translate it into colors our eyes can see. JWST takes multiple images of the same celestial object with different infrared filters represented here in black and white.
We've taken light of different infrared wavelengths and split it up. And so there's long wavelength infrared, medium wavelengths, a little bit shorter, and then shorter wavelengths.
Now, those infrared waves are translated into the colors of the rainbow.
We try to adhere to a philosophy of colorizing the data that we call chromatic ordering.
So we're capturing these wavelengths in infrared light, and we're shifting them into the visible part of the spectrum. And we are assigning colors that represent shorter to longer wavelengths, just like we would see them.
Think of it like a song played on a piano. Transposed, so we're hearing it in a different key, but it's still the same song.
So the longest wavelength is going to be red, so I will make that red. The next longest wavelength, I'll assign that green, and then the shortest wavelength, and that'll be blue. And in this case, we actually have 4 filters. One of them is a narrowband filter that is really isolating a very specific kind of light, and that one we color orange. So after pulling everything together, I see the initial color composite image here, and it's really interesting. There's a lot of potential here, but I also see that it's very flat and it needs some compositional work.
And then this where it kind of goes into the subjective and more into the artistic.
The stars can look very different. The quality of the nebula can look very different. There isn't really like a hard point where it becomes, going from science to art. It's sort of the whole process. The science is always there. We're always respecting the data. We're not trying to introduce things that weren't there in the data to begin with, and we're not trying to remove things that are there. So the whole goal of this is to create an aesthetically pleasing image that will capture someone's attention and hopefully inspire them to want to learn more about this region in space.
This image of the Tarantula Nebula is not only beautiful. JWST's infrared eye reveals thousands of baby stars once hidden from view, providing researchers new clues to decode